milky, nasty, burnt smelling gear oil that's been drained out of an application. Most of you that have done maintenance on your own personal vehicles, work vehicles, have worked in environments where you've done maintenance on planetary gears, gear reducers, you know exactly what I'm talking about. That nasty, burnt smelling, milky gear oil. Why does it happen and how do we fix it? Coming up right now. Okay, so this is actually a pretty easy solution to a number of problems, so I want to run through them real quick. Foaming is your number one enemy in a gear application. Why is that? When cavitation occurs, which is the collapsing of a fluid on itself, basically what's happening is you're sandwiching air. What you need to have happen is you need that trapped air to be released to the surface of the reservoir, to the surface of the oil, to prevent foaming. That trapped air manifests itself as foam, and it insulates your gear set, and it drives temperatures up. Three main things happen when you elevate temperatures in an enclosed system like that. Number one, you deteriorate seal material. Seals and gaskets are made of polymers and rubbers and materials that do not play well with elevated temperatures, especially prolonged elevated temperatures. They begin to crack, draw in. The integrity of the seals is compromised. You have leaks, and you have an ingress of outside contaminants, which then make the situation even worse. So foam leads to elevated temperatures, which leads to basically the cooking of seal material in the gear application. Number two, shortened oil life. So we already know that you're dealing with an oil that has an insufficient amount of non-foaming additive. You have foaming that's occurring, the temperatures have been driven up, you've got seal damage. Now what's going to happen is that oil life is going to be compromised. That oil is going to perform worse tomorrow than it did today and worse next week than it did this week, because the temperatures that the environment that you've created with elevated temperatures is going to cook that oil. And that's going to shorten the oil life, but it's going to do something more. It's going to actually burn the oil to the point where you have lacquer and varnish buildup. Anyone who's ever done a PM or a maintenance on a gear set, they pull it apart, they see this gummy, black, tacky, nasty, sticky mess inside of a gear set. That's lacquer and varnish buildup from overheating of your oil, burning the oil. The foaming is a key component to that. It doesn't allow temperatures to be dissipated properly. That's two things. Your third thing that you want to look at with gear oil is, in addition to the deterioration of seal material and the deterioration of the oil life itself, is the potential for emulsification of your gear oil. When you elevate temperatures during operation and then you shut that equipment down, especially for equipment that sits outside that can see a greater variance in ambient temperature from daytime to nighttime as equipment sits overnight, what happens is you get condensation buildup. And when you have condensation buildup, you fire up that equipment the next day, and what you're doing is you're basically blending an oil and a water mix. You're combining the two. That's where you get the milky consistency. That's why when you drain a gear oil and it doesn't have that nice oily amber look to it, oily consistency, it's more of a milky consistency, you've emulsified that gear lube with water. It's never going to perform right again. Most gear oils on the market don't have the capability of shedding that water, of separating itself. So let's just review real quick. Foaming leads to the deterioration of seal material. Foaming leads to the shortened oil life and the buildup of lacquer and varnish as a byproduct of burning that oil. And then foaming also leads to the buildup of condensation, which then leads to the emulsification of your gear oil in water. How do we fix that? Number one, our gear oils are absolutely boosted to the max with non-foaming additive. It's absolutely a critical part of why our oils last so long. Actually, let's pull up a little quick close-up video that you guys can see. This red sample here is our 646 8090. It's one of our top gear lubricants. You can look and see the surface activity in this video. All of those bubbles that are bursting after we've agitated this sample of oil. That's what you want to see. You want to see the rapid release of air that's going to help reduce or eliminate the foaming, which reduces the temperatures in the gear application. This other sample is an 8090 gear oil, Same characteristics, extreme pressure, meets GL4, GL5 standards, made by a major manufacturer. There's probably thousands of people using this right now, tens of thousands of people using this right now. But look at the surface activity. You don't have the bubbles bursting on the surface. You don't have the rapid air release. That manifests itself as foam. That's going to drive the temperatures up. The other thing that you want to look at, we can cut back to the regular camera now. Here's the 646 sample. These were drawn up just a few days ago. This is the sample that you saw in the video. I want you to look at that line of emulsification. There is water separation, but what you're beginning to see is that you're beginning to see that white line of emulsification. If I shake this up, you don't have the rapid water separation. So imagine this is just running nonstop all day. All day. What you're going to do is you're going to speed the process of emulsification. It's not going to be a sample that was drawn up and sat here over the weekend for the purposes of a video. With our product, what you're going to get is you're going to get rapid water separation. You're not going to get that line of emulsification because you have the ability to shed water completely. With this product, 646 Supreme, SuperTech, Moly SuperTech, what you're actually able to do is drain that water off of your reservoir and continue running. You don't have to worry about the emulsification issues. Plus the non-foaming we talked about, the tackiness, the adhesive and cohesive characteristics, which we'll touch on another video, and why that's important in regards to film strength and protecting your metal surfaces and your components within your gear set. So listen, even if you never do business with us, I say this all the time. When you shop for a gear oil, shop for something that really does an excellent job at eliminating foam. It's going to end all those other problems that you have that come along from the foaming. Again, let's run through them. The elevated temperatures due to foaming are going to lead to seal deterioration, which is leaks and an ingress of contaminants. You're going to lead to shortened oil life, a buildup of lacquer and varnish as that oil is burned. And then what you're going to have happen is that you're going to have condensation build up due to temperature variances, and you're going to emulsify your oil in your water, and you're going to end up with a whole other slew of problems. Give us a call, 1-800-332-1926. We'd love to help you. We'd love to find out exactly what oil is the one that you need for your gear applications, and we look forward to talking to you. Thanks.